All right, in this video, I want to do the entire curve sketching algorithm for this question over here, and it's the calculus curve sketching algorithm. So the first thing I want to do is I want to derive the equation. So if I derive it, I'm going to bring the exponent down, and I'm going to subtract the exponent by 1. That's my derivation right there. And this can be simplified. Negative 3 divided by 3 is just negative 1. So I can actually simplify this to negative x squared plus 2x. Once I derive this equation, I want to make it equal to 0 and solve to find my critical points. So to solve this, I can common factor out a negative x over here, left with x minus 2. So this gives me two critical points at x equals to 0 and x equals to 2. Those are my critical points. The next thing I need to do is a number line, and I'm doing the number line to classify my critical points as either maxes or mins. I'll start by just putting my critical points on my number line. And now I'll test all the different ranges. So I'll try y prime. In this range, I'll just pick -1. I'm going to sub that into my derived equation. You can either do this one or this one. It doesn't matter. I'll do this in my calculator. And I get -3. Since it's a negative value, it means this interval here is decreasing. Then I'll pick a value between these two. I'll pick +1. If I put that in my calculator, I will get 1. Since it's a positive value, it means this interval is increasing. And then I'll pick a value greater than here. I'll do y prime of 3. And if I sub this into my calculator, I'll get -3 again, which means the final interval there is decreasing. So now I can classify my critical points using this number line. If I connect these two here, you can tell that this is a minimum. So we have a minimum and the x value is 0. To find the y value, I'll sub in the x value back into the original equation. If I sub in 0 into this, I'll get 0 plus 0, which is the y value of 0. So my local or relative minimum is just a 0, 0. This point here, if I connect these two, you can tell that that is a maximum right there. So I have a max, and the x value is just 2. To find the y value, I'll sub it in that equation, and I'll just do that in my calculator. And I just get 4/3 as the y value of the maximum. So now I've classified my critical points. The next thing I can do is my intervals of increase and decrease. I only have one interval of increase here from 0 to 2. And I have two intervals of decrease. The first one is from -infinity to 0, and the second one is from 2 till infinity. The next thing I'll do is I'll come back to my simplified but not factored derived equation, and I will derive it for a second time. So if I derive this a second time, I will get -2x plus 2. I'll make it equal to 0, and then I'll solve it to find my inflection points. So I'll just move this to the other side and then divide both sides by 2. So I get x equals to 1. So my inflection point, I know that the x value is 1. And then to find the y value, again, I'm going to sub this back into my original equation. Anytime we're finding points, we always use our original equation. If I sub it into my original equation, I will get 2/3 as the inflection point. Then I will do my intervals of concave up and concave down. So again, I'll do a number line, and on this number line, I will only put my inflection point. I'll pick a value less than here, so I'll pick 0, and I'll do y double prime of 0. So I'm basically just putting 0 into my second derived equation over there. I'll get positive 2. If you get a positive value, it means the interval is concave up. Then I'll pick a value from here, so I'll pick positive 2. I'll do y double prime of positive 2. And if I sub in positive 2 into this equation, I'll get negative 2. Negative value means I'm concave down. So my intervals of concave up are from negative infinity to 1, and my intervals of concave down are from 1 to positive infinity. Finally, I can sketch this out. When sketching, you have a lot of information, but a lot of it, honestly, you don't even require, especially for the easier problems. First thing I'll start with my min and my max. So I have a min at 0, 0. I have a max at 2 and 4/3. Then I'll put my inflection point next, which is 1 and 2/3. And then you pretty much have enough information now to sketch it. You don't even need to look at your increasing, decreasing, concave up, concave down intervals, because you know that this over here is a minimum. Oops, not the best drawing. And then we know that that is a maximum. And we know this area is concave down, that's concave up. Everything in terms of increasing and decreasing will automatically follow along if you just draw the mins and the maxes. The last thing I will do is I will label my points on this graph. I always label my points after sketching because then it's kind of a bit more neat and you won't overlap your points with the graph. Don't need to label 0, 0 because that's just passing through the origin. So this would be the sketch for this question over here. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.